Good morning, my dear students. Myself is Dr. Ganesh. I work as Dean and Professor in the Department of Computer Science Engineering, VEL TECH MULTI TECH Dr. Dr. Sanundala Engineering College, Avadi, Chennai. Today, we will be dealing a topic called test case design from the subject IT6004 Software Testing. It is an elective subject for the third year BE Tech CSE Computer Science Engineering students. What are the test case design techniques? What are the techniques? As far as the test case design is concerned, what do you mean by test case? Test cases, the programmers do their coding job. They do their computer programming, and whatever they do, they get an output. Say for example, they get an output, and when they are going to get an output, we are supposed to test the output, because they cannot show anything and everything as an output. We are supposed to test the output. So how do we test it? So that is what we are going to see in today's session. So in this test, and they are supposed to write a test case. So what are the ways in which they write the test case? The test case design is broadly classified into two groups, two categories. They are black box testing and white box testing. So what is a black box testing? We are not going to deal with the individual levels of testing or the individual testing such as your manual testing, automatic testing, or the unit testing, integration, so on and so forth. But we are, in this session, we are going to deal only with the test case design techniques, which are classified into two categories. One is black box testing, other one is a white box testing. Now, what is a black box testing? A black box testing is a behavioral kind of testing. What do you mean by black box testing? What do you mean by behavioral kind of testing? As that is, see, you give an input, the testing is being done, you get an output. What does this diagram denote? It is nothing but the code is not known to the tester. That is, he will be, the tester will be in a position to test only the functionality of the program, functionality of the code. That is, the code is not known to the tester, which means the programmer, the tester can test only the behavior of the working methodology, how it works. When I am going to pass an input, what will be the output, how the output will appear. So that is what this black box testing will exclusively deal with. So hence it is called as the behavioral testing or the functionality testing, or how the code is going to behave for one particular input, what will be the output. It is because the tester does not have the code in hand. He cannot see the coding at the instance, right? So this is called as black box testing. Now the second category of test case design is the white box testing. So what is a white box testing? In the white box testing, it is the vice versa of the black box testing, where here the code is given to the tester. So supposing if anything happens to the input, if an input has been given and he is not going to get the desired output, he can go and test the code. So hence this white box testing is called as a clear box testing. It is also called as a glass box testing. It is also called as an open box testing. So this kind of testing, this kind of white box testing is also called as a structural testing. Well, my dear students, the black box testing is otherwise called as the functional testing, whereas, or behavioral testing, whereas this white box testing is called as the structural testing or the glass box testing. Wherein in this white box testing, the code is clearly visible to the tester. So supposing if anything happens to the output, that is the tester is not getting an output that has been desired for a particular input, then he has an opportunity to test the code, to run the code again, to make some corrections, to make some manipulations, to identify certain things in the code. That is what the white box testing speaks about. Here the code is visible to the tester, whereas in the other case, in black box, the code is not visible to the tester. So hope you are clear with the basics of the test case design. Now let us see in detail about these two concepts. Let us see about the black box testing. The black box testing, as I said, it is called as a functional testing. Here the tests are divided into 4 different categories. One is subdivided into 4 different categories. One is specification derived testing. Second one is equivalence partitioning. Third one is boundary value analysis. Fourth one is state transition testing. And again, next, this white box testing. As I said, the code is visible in white box testing. Here we have branch testing. We have condition testing. Condition testing, something like your if then else. We have the data definition use testing. We have internal boundary value testing. And the other kind of testing is the error guessing. Error guessing is, say, this is just like a trial and error method. Trial and error method. So for this input, I expect such an output. So I expect we are not testing it based on certain functionality. So that is error guessing. Error guessing is I guess and there is a probability that it may come right. There is also another probability that it may come as false. Fine. So now let us go into details of this first and foremost black box functional testing. So in this black box testing, first let us speak about the specification derived testing. What do you mean by specification derived testing? In the case of specification derived testing, it is one of the positive test case design technique. So here, this specification derived testing, it works based on the test cases are written based on the specifications that are given. So my dear students, you might be knowing before we could write any test case, we have our specifications that is to be written. Even when you write before you go in for this taking up the requirements, you have to write the SRS. Hope you might be knowing, you would have studied in your earlier subject also training how to write an SRS. SRS is the software requirement specification. Similarly, here you have STS. STS is software testing specification. So, and this particular black box behavioral testing, this particular specification derived testing works based on the specifications that has been written, right? Let us see an example for this. Consider this example. So, if I want to find the square root of a particular number, right? Say for example, if I'm going to give the input as 4, what is the square root of 4? Correct. The square root of 4 is 2. Now, if my input, if I'm going to give input as -4, what is the square root of -4? Here, if it is less than 0, it should raise an error. If the number is greater than 0, it should give the output. So, the square root of 4, my input is 4. Here, 4 is greater than 0. So, hence the square root of 4 is 2. Whereas if I'm going to give it as -4, so which is less than 0, it should raise an error. So this is my specification. My specification is if the number is greater than 0, print the square. If the number is less than 0, display an error. So it works based on the specification test. So that is an example for specification derived test. Now let us see the next kind of black box testing, that is equivalence partitioning. What is equivalence partitioning? Here again, in the input, that is, you have I said, when you are going to give a set of inputs, you get a set of outputs. So something internally it happens, right? So now here equivalence partitioning is, you divide the input and output separately, right? That means, what does it mean? For this particular input, I want this particular output. For the other particular input, I need a different set of output, right? And if it is going to mismatch, then it is wrong. Then the test case fails. So, if I want to have, if I am going to give my input as 4, for the square root example, I want the output as 2, because square root of 4 is to be 2. If I am going to give the input as -4, I want to get the output as, it should print as, the number should be in a positive number, the number should be a positive number. So, that is an error. So, supposing if the output mismatches, speaks about the equivalence partition. That is, you are partitioning the input separately, you are partitioning the output separately. Let us explain with an example, the same old example of finding square root of a number. Here, you have the input partition, output partition. If my input is less than 0, it should print, if my input is greater than or equal to 0, it should print the output. That is, if my input is 4, the square root of 4 will be 2. If my input is minus 4, it should print as error. So, that is how the equivalence partitioning works out. That is, the input and output get partitioned. So, let us see the third type of the black box testing. That is about test case design techniques. The third type is about the boundary value analysis. What do you mean by boundary value analysis? You would have seen this even in your mathematics. Even you would have had the lower boundary and upper boundary. That is, you cannot test anything in a supposing if I am going to give a random number. If I want to find a random number, if I want to get a random number between 10 and 50, then my input should be definitely between 10 and 50 only. If I am going to give the input as 5 or 0, right, it should result in an error. If I am going to give an input as 55 or 60, it should result in an error because my lower range input is 10, the upper range input is 50. So, whatever value that I should give, it should be in the range between 10 and 50. The lower range is 10, the upper range is 50. So, that is called as boundary value analysis. Here, let us see an example. So, here also, this is based on, this is also similar to an equivalence partitioning. That is, here the input, the lower limit and the upper limits are specified. So whatever input that you give, it should pertain or it should provide within the extent of the lower limit to the upper limit, between 10 and 50. It should not be either less or it should not be greater than the upper limit. If that is the case, then the test case can fail. So the test case are designed to exercise the software at either side of the boundary values, between the lower and the upper limits. Right? So this is one of the negative kind of testing into the test design. So let us see again the example of the boundary value. So here the input is for the square root of 4, right? So if it is less than 0, it should get an error. If it is greater than or equal to 0, it should print the output. See, this is 0, this is the lesser lower limit, that is upper limit, right? So here I am setting the boundary value over here as 1, the lower limit, the upper limit as 5. So within this range only, I can specify, I can give my inputs. Hope you are clear with this. So next type is the state transition testing. It is also one of the black box testing, which is a functional testing, which is a behavioral testing. So in the state transition testing, what does, as the name specifies, the state transition testing, as the name specifies, it works based on the transition of states. What do you mean by transition of state? Hope you would have studied in several subjects, in different subjects as the input state and the output state. So before you have an input state and output state, you have certain transitions. Say for example, let me give a real-time example. You are riding in a bike, right? You start your bike, right? You start your motorbike. When you want to start the motorbike, you put an ignition key, you switch on the bike, right? Say for example, your bike has been started. That is said to be a starting position. That is said to be a starting state. And if you want to go to your college, right? And your college will be the destination point, that will be the end position. So from your home till your college, when you want to move on, what are different states that you encounter? You press the clutch, you change the gears, you gear up the accelerator, right? You increase the speed, you decrease the speed by applying brakes, you change the gears, right? These are different states that you encounter, different transitions that you encounter between the starting position and the destination. After you start from your home and before you reach your college, so these are the different transitions that happen. Similarly, here in state transition testing, the test transition happens based on the transition modes, based on the different state transitions. So that is called as the state transition testing. It is also one of the behavioral testing, one of the function testing, one of the black box testing approach. So it happens based on the events. When you apply a brake, the speed automatically reduces. So that is an event that is happening. So even here in programming, in testing, it works based on the different kinds of events, different kinds of the runtime events that is happening. So it works based on the different test transitions. So next, so these are all classified into, these are all segmented or categorized into the black box testing, behavioral testing. My dear students, you might be knowing that this black box testing, wherein the code is not known to the tester. When he is going to give an input, he gets an output, the desired output. So that can be achieved using the above mentioned techniques. Now, let us go into the second category of the test case design techniques, that is the white box testing, or it is also called as the glass box testing, or it is also called as the clear box testing, or it is also called as the open box testing. It is also called as the structural testing. Why is it called structural testing? Because the code is visible to the tester. When the code is visible to the tester, supposing if he is not going to get the desired output, he has every chance to get into or to peep into the code, to look into the code, what is wrong with the code, because anything and everything matters based on how it works, based on the code that has been created, right? So he has every chance to look into the code, to have an access towards the program, right? So in this white box testing, the white box testing is classified into 4 different kinds of testing. One is branch testing, second one is condition testing, third one is data dimension use testing, fourth one is internal boundary value testing. Now, first, let us go into this branch testing, which is part of white box testing. So this is designed to control the flow of branches. For example, if then else. So how does it work? If this condition satisfies, it works. It prints a value. If it is not satisfied, it goes to the else condition. So it branches to a different location, or it jumps, or it breaks. It breaks from the condition statement. It comes out of the condition statement, and the program abruptly stops. So that is called the branch testing. Next is the condition testing. What do you mean by condition testing? Even for condition testing, even if then else is also, you can work for condition, and even looping also, you can work for condition. Okay, what is the difference between working with a condition statement and working with a looping statement? Is that as far as the condition statements are concerned, as far as the previous example, we saw what if then else. In if then else, if the condition works, is true, then execute this particular statement. If it is false, do not execute. That is what my query is, right? Here, as far as if then else condition statement is concerned, it works only once. Whereas in the case of while loops, whereas in the case of for loop or while loop or do while loop, for loop and while loop we call it as an entry criterion loop, whereas do while loop we call it as an exit criterion loop. What does it mean? As an entry criterion loop, here the condition is checked first and then the loop is executed. Exit criterion is the loop is executed, the condition is checked at the last. So here in the while loop, the condition is checked. If the condition is working correctly, then the set of statements gets executed repeatedly until the condition falls. Whereas in the case of if then else, it checks only once. Whereas in the case of looping, it checks several times, several iterations happen until the condition fails, that particular loop So it is a kind of conditional testing. It is a kind of white box testing, kind of structural testing. So the next testing is about the data definition use testing. What do you mean by data definition use testing? So here the objective is to create the test cases, that is, it works, the execution works between the paths specified by the data. What does it mean? Here you give a specific set of data and that particular data has to work. For example, if my input is, say for example, again let us take an example of finding a square root of a number. If my input is, I am asking the input from the user. Enter the input of a number, enter your number, and the user is supposed to key in only numericals 2, 3, 4, 5, 6, 7, 8, etc. so on and so forth. Supposing if the user types the input as A or B or C, you might be knowing, my dear students, A, B, C are not numerals, are not integers. Only numerals are 2, 3, 4, 5, 6, so on. So that particular user, he has to specify only numeric values. If he is going to give any other value, then it encounters an error. So the value, the output depends upon the data that is being shared, that is being given, depends upon the input that is being given. So that is called as the data definition use testing. So this is one of the white box testing. Now last one is internal boundary value testing. It is similar to your behavioral testing wherein you have boundary value analysis. Even here, this boundary value testing works based on the lower limit and the upper limit. The major difference over here and over the black box testing is that as in black box testing the code is not visible, whereas in white box testing the code is visible, the limits are visible, lower limit and upper limit is visible. So if anything goes wrong, the test case fails. So the tester will be aware that he has to give an input only within the specific limits between the lower limit and the upper limit. So that ends your white box testing category. So here white box testing, you have this many testing: branch condition, data definition, internal boundary value analysis. All these test cases works based on the code available. The last but not the least, let us see about the error guessing. Error guessing is, as I said in the initial point of our session, error guessing is it works based on the experience of the tester. If I have somewhere around 5 years or 10 years of experience, and if I have a monotonously working on a particular test case, and if I know that for this particular input I will be getting only this particular output. If I know pretty well, so before I could execute any specific test case based on my experience, I pretty well know the output will appear only like this, then I can suggest my own testing views. It works based on trial and error. So that is called as error guessing. So it works based on the experience of the tester. Then the test cases are designed for the values which can generate errors. It is only a probability. We are not sure. It works based on the tester's experience. So that is about the error guessing, right? Thank you, my dear students.